Before I start my talk, I would like to ask you some questions. First of all, who knows what Selenium is? Just raise your hand. OK, that was a stupid question. No. And then, who is using some commercial services online? So just Sauce Labs, Browser Stack. OK. So, and who is maintaining, just trying to deploy your own cluster, Selenium cluster? OK. Was it easy? OK. So my name is Ivan Krutov, and today I'm going to talk about scalable Selenium cluster. A few words about me. Being a software developer during the last 10 years, my main experience is related to Java and Golang programming languages. I also actively participate to open source projects. For example, I did a lot of contributions to Allure Framework, which is a test execution report. My main activities during the last 4 years are called with a buzzword, DevOps. That means that I'm creating and maintaining infrastructure. And the biggest product I'm working on is a big Selenium cluster. So how big is this cluster? Compared to a typical Selenium grid, having 50 browsers and 10,000 sessions run per day, my cluster contains more than 5,000 browsers, running more than 1.5 million sessions per day. These browsers are distributed across 5 data centers. The average load is about 4,000 requests per second, and this cluster traffic is about 800 megabits per second, and this cluster is highly available, working all the time. So this cluster has all popular browsers and platforms available, including last 10 versions of Firefox, Chrome, Opera, all versions of Internet Explorer, Microsoft Edge. We also have Android emulators running on Linux hardware servers. We have iOS simulators running on Mac Minis. And for some teams, we also have real devices. That means phones and tablet PCs connected to the same cluster. So you can see that compared to a typical Selenium grid, my cluster has completely different scale. So how did we achieve that? What's the key difference? We do not rely on Selenium Server. And more than that, we think that Selenium Server can be a time bomb for scalability. So you can work in a big company or participate to a small team or even be an individual developer. So let's see how doing a wrong decision affects your productivity. So let's assume first that you have started your company alone and working as an individual developer. In that case, you have a lot of things to do and only 2 hands. And browser automation tool you need to use should be, first of all, easy to install, very simple to use, reliable, requiring no maintenance, briefly working out of the box. And who knows how Selenium Server works? Just raise your hand. OK, a few hands. So you should have heard about 3 main Selenium components. Selenium Server, which handles your test commands, the browser installed in your operating system, and the WebDriver, which translates your test commands to your browser-specific commands. Having such elegant architecture, Selenium Server unfortunately has no fully automated installation procedure. So you have to do a lot of things manually. Manually install Java, manually download Selenium jar, manually download WebDriver archives, manually unpack these archives, manually install required browser versions, and finally manually type complicated startup command. What is more depressing that a smooth installation doesn't guarantee a successful usage. So when using Selenium Server, you will sooner or later encounter one of the following problems with your tests. For example, trying to run several browsers in parallel can lead to flaky tests because of browser windows struggling for window focus. And any checks in your tests, depending on window focus, can be affected by this issue. Sometimes your browser can stop opening the pages at all. A few accidental clicks in browser settings can stop your testing conveyor. Sooner or later, you will understand that having two versions of the same browser is impossible in your operating system. This is how package managers usually work. So, and from time to time, you will also need to solve the following puzzle. For example, having Chrome 56 installed in your operating system, which Chrome driver version should I use? So who knows here? Nobody? Okay. I don't know. I'm not an expert. And because of that, you will often need to go to WebDriver documentation to check this information. And this is what you were initially expected to avoid. So you can see that now I enumerated only a few problems you will encounter when using Selenium Server. And the problem is that Selenium Server is a bad foundation for your cluster. So we need a better solution. Let's analyze the following two facts. First, most of these problems I told you before are caused by the lack of isolation between browser processes. And second, Linux operating system covers 80% of your browser needs. So what's not covered by these 80%? First of all, Windows-only browsers like Internet Explorer or Microsoft Edge, and also Apple browsers like Safari and Safari Mobile. And some of you already know the answer. We should use containers where possible. So here is how it should work. All your browsers should be packed to Docker containers. And when you test requests a new session, a new container with desired browser version should be started. When you test a request to finish the session, this container should be removed. And in that case, your operating system will remain in just the same state as it was before launching the tests. And you know, this functionality should have been implemented 3 years ago with the wide introduction of the Docker platform in 2014. And we had already been waiting 2 years for this feature when we decided to implement our own solution for this. This new solution is called Selenoid. And I'm quite sure that it will soon bury Selenium Server. So, the most important Selenoid feature is that it runs browsers in isolated containers. So every container has inside everything you need to run the test. This is a buggy slide a bit. Okay. First of all, an X server to start your browser. Then compatible version of the WebDriver and the browser. And finally, some other stuff like fonts or Flash Player needed to correctly show you the page. So Selenoid comes with a collection of ready-to-use and available for everybody images for all recent browser versions, including, first of all Firefox versions starting from 3.6. That means all Firefox versions. All Chrome versions above 48. All Opera Blink versions above 33, and for some old tests, you will also need Opera Presta 12.16. So all these images have a remarkable feature. They can be run with any custom screen resolution you want. Here's how it works. So you should add to your test just one capability called screen resolution. And when you then run your tests, your browser will be started on the screen having exactly this resolution. So this allows you to easily test, for example, responsive HTML layout with parameterized tests. So a short demonstration is better than 1,000 words, so let me show you how it works. I prepared a small video, just 5 seconds. Okay, here it is. So installing this tool is really straightforward. I'm showing all this stuff on the virtual machine, but you can do this on your personal computer. So here I'm logging into a virtual machine, and I have already Docker installed here, and I'm checking that there are no containers running here and only a few standard images available on the operating system. Then I go to GitHub, to our page, and download a small binary for an automated, fully automated installation tool called CM, that means Configuration Manager. So here I download this tool with wget, as usually, and so downloads. Just I'm a bit accelerating the video here because the virtual machines in DigitalOcean are a bit slow sometimes. Okay, so here we download a 10 megabyte binary, and then we add execution permissions to this binary and launch one simple command to install a ready-to-use Selenium tool. So it looks like that. CM Selenoid start with the VNC support. That's it. This command will do the following. It will download the latest release of Selenoid, as well as all browser containers to a machine. It will automatically generate a JSON configuration for this tool and start this tool. So after running just one command, you will have Selenium running and ready to execute your tests. So here you can see that after running this command, we have one new container listening on the standard Selenium port 4444 and ready to run the tests. So Selenoid has a standalone user interface compared to Selenium Grid, which has Grid Console, as you know. And to install it, we type just almost similar command, CM Selenoid UI start, which installs you the latest release of this UI and starts it. So now we have two containers. One is the Selenium standard port, and the second one is an HTTP port. Okay. And we also have new browser images downloaded to our operating system here. So now we can open the page with the Selenoid UI, like you are doing with the Grid Console. So here I'm typing an IP address of the machine and opening the new user interface. It looks like this. It's a React application. So here we can see a list of browsers as well as code snippets with capabilities that you could insert to your tests. We also have detailed statistics of the browser usage, as well as two tabs for showing the browser screen and for showing its logs. So now I'm running some tests, some example tests implemented in Java that do a very simple thing. They open the DuckDuckGo page and type the word Selenium in the field and press enter. So I'm running the test. And here I will now see a rectangular button like this. Like this. When I click on the button, I'm seeing the browser screen and the test being executed inside. So it types the word Selenium, clicks on the button, and I can even intercept my tests with the mouse. So you can see the mouse. I can just click on the browser buttons. Okay. And now I will run the same test again to demonstrate how you could look at the real-time Selenium log stream. So I'm running the test. I'm seeing the same rectangular button. And here are the Selenium logs that you could use in your usual work to debug your tests when they are not working for some reason. OK. So that's the end of the first demo. OK. Now, an individual developer sooner or later becomes a small team. So do you recognize Bill Gates here, the left corner? Here are the first 11 employees of Microsoft. So in such small team, you have several developers requiring browser automation, but not enough hands to do Selenium infrastructure research. How could we deal with such situation? Very easy. We need to just move our Selenium installation from our working computer to a virtual machine in the cloud or to a real server. And when we need to add more browsers, we need to just resize the virtual machine or take a bigger server, more powerful server. Unfortunately, all these simple solutions don't work for medium companies because these companies already require hundreds of browser sessions being run in parallel. And you cannot deliver such quantities of browsers using one server or one virtual machine. And here we need a real cluster. So how should this cluster be? First of all, it should be fault tolerant. That is to say, you should be able to distribute your browsers across multiple data centers, and this cluster should remain alive even if one or several data centers go down. It should be scalable. You should be able to add new data centers as well as more browsers to existing data centers with no downtime. This cluster should provide the standard Selenium API. That means it should look for the tests like a single Selenium server. This is very important because all your standard Selenium clients can only work with one Selenium hub. You should have full access control by defining users and full browser consumption control by assigning different quantities of browsers to every user. So I think some of you should know at least one Selenium cluster architecture called Selenium Grid. Described in a lot of articles, this architecture consists of a hub distributing your browser sessions across one or more nodes, really executing the tests, running the browsers. So a deeper investigation of this architecture shows that Selenium Grid is not fault tolerant. Your Selenium hub can be installed in only one data center, and if this hub goes down, the entire cluster becomes unavailable. Selenium Grid is not really scalable because Selenium Hub is using HTTP network requests to ping your nodes whether they are alive. And this is, in case of big cluster, this is really the parasite network traffic, useless. And you still have no access control here. So what could we do? One possible approach is the so-called client-side load balancing. This is how it works. You need to install several Selenium hubs to multiple data centers and implement a small library randomly distributing your browser sessions across these hubs. So you should use this library in your tests, and when you test requests a browser, this library should randomly select one host from the list and try to create a session on this host. In case of failure, it should randomly select another host, and it should continue these attempts until either a new session is created or all the hosts return an error. So you understand that in order for the scheme to work, you need to somewhere store the lists of the hosts you have. And this can be, for example, an XML file having several sections, one per browser, as well as browser version information inside, the host names, the port names, and the data center information. So compared to Selenium Grid, this scheme has some advantages. First of all, it's fault tolerant because you have multiple data centers, and even if one goes down, your cluster continues to work. This approach is already scalable. You can easily add more and more hosts to a cluster. But unfortunately, you still have no access control, and which is more important, this is not standard Selenium. So this client-side approach will not work if you are not using this library in your tests. Without the library, it doesn't work. And while you can use this client-side approach in your tests, in some situations, for big companies, it's not applicable because in big teams and big companies, you usually have multiple teams using different technologies. For example, Java and Python for backend development and JavaScript for front-end development. And maintaining client-side libraries for several languages is too much work. So we need a better solution for this situation. So how could we solve this? We need to do a very simple thing. We need to move this client-side logic to the server side. And the server should have the standard Selenium protocol in order to work with standard Selenium clients. So during the last few years, we did several implementations of this logic. And the latest and greatest one is called the GoGrid router, or just shortly GGR. It's an open source tool. You can just use it right after my talk. This GGR is using a lightning-fast Go programming language and is distributed as a small 6 MB binary with no external dependencies like Java, for example. And this server consumes under 400 requests per second. It consumes only 200 megabytes of memory. So GGR already supports authentication users. That means that in order to run your tests, you need to only modify an URL to your Selenium cluster. You should add the username and the password like shown here. Okay, so another problem you can encounter when creating a big cluster is the multiple data center problem. So in order for a cluster to be really fault tolerant, you should have multiple instances of this GGR server. And as you probably know, Selenium is using HTTP requests for every action. For example, to start the browser, you are sending an HTTP request. To open the page, that's another HTTP request, and so on and so forth. And when having multiple data centers, you can have the following situation. For example, consider the first request to start the browser is arriving to the first GGR server. And it creates a new session on some host among your servers. And then the second request arrives to the second GGR because requests are usually distributed randomly across the servers. And the question is, how would the second GGR understand to which Selenium hub it should route the session? So you can use, as a simple solution, you can use some shared storage like database or in-memory data grid. But we personally did a better choice. So what we are doing is called the session ID magic. As you know, somebody knows, I think, that when you create a Selenium session, every session gets an identifier like this. So you can see sometimes in stack traces such identifiers. And what we did, we first of all calculated a MD5 hash sum of the host name and the port, and then we just added this information to the session ID. So this information about session ID is transferred in every HTTP request while tests are exchanging with the Selenium server. And because of that, our solution is completely stateless. So all information about the host where the session is actually running is stored in the session identifier. So GGR, compared to Selenium Grid, doesn't require any registration procedure. And because of that, scaling the cluster becomes just a trivial task. So you can independently add more GGR instances behind Network Load Balancer, as well as more browser hosts with no downtime. And you can scale with no downtime because the server is reloading its configuration when receiving the Linux signal, SIG-hub. So when you send a signal like this to the server, GGR automatically reloads its configuration without interrupting any running browser sessions. So here is one more demonstration for those who are already sleeping. Okay, it's shorter than the first one. So here I have 3 virtual machines, 2 with Selenoid in my case, but you could use just Selenium Hub, and the third one with the load balancer. Here I'm installing only one package, Apache Utils, to have a tool called htpassword, just to create the passwords file. So I'm creating a passwords file having only one user test and password test password. Then I create an XML file like I showed you before on the slide, looking like this. So here I have browser name, browser version, 2 data centers, Amsterdam 2 and London 1, as well as IP addresses of my virtual machines, their ports, and total number of browsers on each host. So it's very, very easy. And then, in order to start the load balancer, you need to just type one command, one Docker command, like this, with mounting some volumes, forwarding some ports. Okay, like this. You can copy-paste from documentation. No need to remember. And when you type this command, you are getting the same Selenium API running on the standard port like you were using before, 4444. And now we can run our tests. The only change we need to do in the tests is to add username and password. I think some of you who are using Sauce Labs already know such notation. So I run my tests, and here I'm seeing 2 log files of 2 servers behind the load balancer. As you can see, they are receiving requests randomly. Receiving requests, okay. Receiving requests randomly. Okay, that's it. So your sessions are distributed across your hosts. The last thing we need to talk about is what to put behind this load balancer. So I think you would agree that when working with big cluster, it's very important to use the software that consumes, that has small resources consumption. You should also have control over logs and statistics flow, as well as being able to do any modifications with no downtime. So from the resources consumption perspective, Selenoid, compared to Selenium Server, is distributed as a small binary with no external dependencies, consuming 10 times less memory than Selenium Server. Because yesterday there was a talk saying about the memory consumption of Selenium Hub. Okay. In addition to low resources consumption, Selenoid gives you not only the full control over the total number of sessions being run per host, but you can also control total number of CPUs and memory for each browser session. If you have some free memory on your server, you can dramatically accelerate your tests by using Selenoid, because Selenoid can move all slow operations like working with cache, cookies, and temporary files from the hard disk to memory. You will also appreciate an ability to automatically send all logs of your browser sessions to some centralized storage. For example, the well-known ELK stack. That means Elasticsearch for faster log search, Logstash for initial log processing, and Kibana as a user interface to view the logs. In big cluster, you also need to have to get browser consumption statistics. And Selenoid, compared to Selenium Server, provides you this information out of the box. You can use open source tools like, for example, Influx Data Telegraph to collect this data and save it to one of open source storages like Graphite, InfluxDB, or Elasticsearch, and then use an open source visualization software like Grafana to have the charts. So finally, at the end of my talk, some numbers. Selenoid Server has already been downloaded from Docker Hub more than 10,000 times, and our browser images are even more popular. All these tools I told you today have a detailed English documentations covering all usage aspects, so free to use for everybody. And to conclude, you now know a lot more ways to have really scalable and fault-tolerant cluster with the open source tools. Please stop using Selenium Server. Trust me, browser automation can be painless. And at the end of my talk, some references. So here we have links to GitHub source code pages where you can have also the links to documentation, examples, and so on and so forth. We also have here our Twitter, our Telegram support channel. So if you have any questions, just arrive. We are answering to any questions in English, just no problem. And we also have here, I also mentioned our website, having the links to some articles just about Selenium, about big clusters, about how to run Selenium under Windows, and so on and so forth. And finally, for those who want to contact me directly, here's my email address. So thank you for your attention, and you can ask your questions.